Consider the situation with friends sharing sweets. Let's suppose for illustration purposes that we have 48 sweets to share. If there is only one person, that one person will get 48 sweets. If there were two, they'd get 24 each. If there were three, they'd get 16 each. And if there were four, they'd get 12 each. Note, as we go this way, the number of people sharing is increasing, but the number of sweets goes in the opposite direction. So as the number of friends increases, the number of sweets decreases. If we made a formula and we said that S were the number of sweets each person gets, we can see this formula is 48, the number of sweets, divided by F, the number of people sharing the sweets. This is a classic inverse proportion formula. S and F are inversely proportional. As one increases, the other decreases. Another situation which leads to an inverse proportion relationship is that of light intensity. We're going to discuss here something that is an actual law of physics. If we have a light source here, which may be something like a light bulb or the sun, then we're going to receive light at a point here, a distance d away from the source. The intensity of light we receive is I. Now suppose that we move further away from the source. If we double the distance, then we don't just half the amount of light, we actually get 1/4 of the amount of light. 4 is equal to 2 squared, and this type of relationship is known as an inverse square relationship. We could make a formula saying that intensity is equal to some constant divided by the distance from the light source squared. We say that I, the intensity of light, is inversely proportional to the square of the distance.